Welcome back to my channel Chiru's Aspirations, and today we have another video of the real numbers of class 10 CBSE. As I said initially, there are many videos of the same chapter real numbers. I have done the basics, the Euclid's division algorithm and also Euclid's division lemma. You can click the I button and go to all those videos and come back to this video. We'll start learning another inspiring aspect of the concept of mathematics. So every week I'll be coming up with practical application and mathematics where we can see in our nature, in our surroundings. And go to the description and click the link and you can watch those videos also. And in today's video we are going to see that is the prime factorization method, that is the fundamental theorem of arithmetic. What's this fundamental theorem of arithmetic? So before going to this, if you like my video, like it, share, comment and don't forget to subscribe my channel. We'll have a great journey through mathematics and I'll be coming up with the NCERT exemplar problems for competitive exams also. And later on, after completing all these chapters, I'll be doing the fascinating science concepts also. So subscribe my channel and click the bell icon to get the notifications for you. And coming to this fundamental theorem of arithmetic. What's this fundamental theorem of arithmetic? Yes, so it's nothing but the theorem states that a particular number will be reduced to its multiples where it cannot be further divided. Likewise, it is prime factorization method. See, for example, if you take any number like 36, 36 is a number, we can divide it by taking 2 into 80 is 36, and again 2 9s are 18, 3 3s are 9, 3 1s are 3. So these are the numbers we got, that is 2 18s are 36, 2 9s are 18, 3 3s are 9 and 3 1s are 3. So these are the numbers which are called as prime numbers, 2 into 2 into 3 into 3. So 36 can be written as 2 square into 3 square. Coming back, I'll tell you what is this prime numbers and composite numbers. The numbers which cannot be divisible by any other number, which cannot be divided by any other number, that number are called as prime numbers, whereas the composite number is the opposite for prime numbers. So in prime numbers, for example, 2 and 3 are prime numbers. So this number cannot be divided by any other number. Whereas composite number is the opposite for prime number. We can divide that number. For example, 36 is a composite number. We have break that number into different forms of prime numbers again. So whatever the number we take, composite number, if you further go on breaking that by dividing, finally we'll get numbers which are prime numbers. So this method of doing the prime factorization, getting the prime numbers, and through this if you find HCF and LCM, then that is called as the fundamental theorem of arithmetic. So we'll be using this. So whatever the number, when we divide, we'll be getting the respective prime numbers. So keeping this, we are going to find HCF and LCM. As I told you what is about HCF and LCM. So HCF, you can go to my previous video, click the I button and go to that video. I have explained a lot of many things about HCF, that is highest common factor. I have given many activities also. And now here LCM is nothing but the least common multiple. Overall, if we want to tell, HCF is the highest common factor for given numbers. If there are 2 or 3 numbers, for example 36 and 18, for these two numbers, which is the highest common factor. So you know that what is factors? Factors are the numbers which multiplied gives a particular number. So here 36 and 18, if I take the factors, for example, what are the factors of 36? We got 36 is equal to 2 into 2 into 3 into 3. Again we can take this as whatever the possible things, and again 18. So for 18 it is 2 9s are 18, 3 3s are 9 and 3 1s are 3. So we will be writing for 18 it is 2 into 3 into 3. So this 36 can be written as 2 square into 3 square, that is equal to 2 into 3 square. Now for finding HCF, we'll be taking the number, the common prime number, okay, prime factors, which the least power. So here we'll be having the least exponent, that is 2. If you consider this is common, and least exponent is 2. 2 to the power of 2, 2 to the power of 1. This is the least power. I am going to take this and into. This is also common, but both are common. We can take them. If this was, for example, 3 cube and 3 square, it would have been chosen 3 square. So here 2 into 3 square, that is 2 into 9, again 18. So 18 is the HCF of 36 and 18. So this way you can divide a number by the fundamental theorem of arithmetic. So that theorem tells us how can we divide this particular number into different prime numbers in a unique way. So by using the fundamental theorem, we can solve for HCF and also LCM. So here we found HCF, and LCM is nothing but the least common multiple. If you consider two numbers, for these two numbers there should be a multiple, there should be a number, so that these two numbers will divide that exactly. So for example, here the LCM we can take by taking the prime factorization method only. So we have the prime factors of 36 and 18. For LCM, I told you for HCF, you should take the least power, the common factors, and here you should take the maximum power. For 2 it is 2 square. For 2 it is 2 square. Both are common, but the highest power I am taking for LCM. So 2 square, and here it is again 3 square. So this becomes 36. So 36 is the LCM for 36 and 18. Now we are going to find the HCF and LCM for these three numbers 6, 72 and 120 using the fundamental theorem of arithmetic. Now we find the prime factors of 6 first, and 72 and 120 one by one. First let me take 6. So 6 is 2 3s are 6. Again 3 1s are 3. So these are the prime factors. So 6 is equal to 2 to the power of 1, only 1, into 3 to the power of 1. Let me take the next one, that is 72. So 72, if you start dividing this, 2 3s are 6 and 2 6s are 12. So 2 1s are 2 and 2 8s are 16. 2 9s are 18. 3 3s are 9 and 3 1s are 3. These are the prime factors of 72. So for 72, I will be writing how many 2's you have? 3 2's here. So 2 cube will be writing and into 3 square. So here up to I get 1, I should divide this, and here I got 1. So 2 and 3 are the prime factors of 6. So I have taken that in its powers. And here also for 72, I have taken all these things. And finally we have 3 2's here. So 2 cube into 3 square. And again coming to this one, 120, I am going to divide this. So 2 60s are 120, 2 30s are 60, 2 15s are 30, and 5 3s are 15, and 3 1s are 3. I got so many things. So what are the prime factors I got? So sorry, let me start with a 3. Okay, always from the least prime number you go on dividing. I will be coming from here. 3 5s are 15 and 5 1s are 5. So this is okay now. And now for this 120, I will be taking, that is 2 cube into 3 to the power of 1 into 5 to the power of 1. Now we have taken the prime factors of all the three numbers, that is 6, 72 and 120. Now our aim is to find the HCF and LCM. Simply HCF is nothing but, so HCF of these three numbers, that is 62, 6, 72 and 120 is just multiplying the common factors of least power. If you consider 2 is common, right? So here also we have 2 cube, here also we have 2 cube, here we have 2 to the power of 1 for 3 numbers we are taking. Out of all the 2 are common for 6, 72 and 120. So the highest power is 2 cube, the lowest power is 2 to the power of 1. So for finding HCF, I will be considering the number with the lowest power. So 2 to the power of 1 into, again let me take 3. So here 3 is common. So 3 to the power of 1, 3 square and 3 1. Again I will be taking the least power, that is 3 to the power of 1. Now 5 is not common to all the 3 numbers, so I will avoid 5 in case of HCF. Now 2 into 3 is 6. Therefore 6 is the HCF of all these 3 numbers, 6, 72 and 120. This way we can find the highest common factor by using the prime factorization method or the fundamental theorem of arithmetic. Now we have found HCF of all these 3 numbers, that is 6, 72 and 120. I repeat, HCF is nothing but the product of the common factors with the least power. So here 2 and 3 are common for all the 3 numbers, so I have chosen 3, 2 and 3 with the least power. Here we have 2 to the power of 1, 2 to the power of 3, 2 to the power of 3. So among 2 to the power of 3, 2 to the power of 3 and 2 to the power of 1, this is the least. So I have taken that for HCF, I repeat. And again for 3, if I consider 3 is common among all these 3 numbers, so 3 square, 3 to the power of 1 and 3 to the power of 1, I am going to consider the least power, that is 3 to the power of 1, that becomes 6. So this is the method of finding HCF by using the fundamental theorem of arithmetic. And next, coming to the LCM. LCM is also simple. Here we will be focusing on the largest power. So for HCF, we took the numbers with the least power. For LCM, what we are going to do, we are going to take the common numbers with the greater power and the remaining numbers also, the remaining factors also. Here for 2, the 2 is common, but I am going to consider the larger power, that is 2 cube. Among these 3 things, 2 cube is the larger power. So I am going to take into, again 3 is common. Among 3 to the power of 1, 3 square and 3 to the power of 1, 3 square is the larger. So I am going to take that for LCM into the remaining number I am going to take, that is 5. So 3 3s are 9 and 2 2s are 8, 9 8s and this is 360. Now we found the LCM. So this particular number 6 divides all the 3 numbers exactly the highest common factor, whereas the LCM, this particular number 360, what we got, 360 divided by 6 or 360 divided by 72 or 360 divided by 120, it exactly divides. So this way we found LCM, that is least common multiple and highest common factor by the fundamental theorem of arithmetic, that is prime factorization method. Now we'll solve another problem for HCF and LCM by using the fundamental theorem of arithmetic. And also at the end of this problem, I'll be teaching you the relation between LCM and HCF. So here the same procedure, we are going to take this number 12 and I'm going to find the factors of this. So the factors of 12 is, let me start from 2, 2 6 are 12, 2 3s are 6, further I cannot divide 3 by 2, so I am going to take 3 1s are. So 12 is equal to, these are the factors, that is 2 into 2 into 3. So similarly I am going to take 15. So I'll be starting from 2, but 15 we cannot divide 2, so I am going to take 3. So 3 5s are 15, again 5 1s are 5. So the factors of 15 is 3 into 5. Similarly I am going to take 21. So 2 I cannot divide here, so I am going to take 3. 3 7s are 21, again 7 1s are 7. Again 21 is equal to 3 into 7. So what all the factors we got? For 12, it is 2 times 2 and 3. So I can write this as 2 square into 3. So now the factors of 12 I have taken 2 times 2 and 3. I have written here 2 times 2 into 3. Again for 50 I am going to take, so that is 3 into 5. So just 3 into 5 I am going to take the power as 1. And again for 21 I am going to take this as 3 to the power of 1 into 7 to the power of 1. As we know, HCF is nothing but the product of the factors, common factors with the least power. So if I consider 2 is not common here, and 5 is also not common to all the 3 numbers, even 7 is also not common to all 3 numbers. The only common number for 12, 15, 21 is 3. So all the 3 has a single power, so let me take 3. So 3 is the HCF for all these numbers, that is 12, 15 and 21. If you come to LCM, so it is the product of highest powers, that is the common prime factor. So here if you take 2, so 2 is not common here, but 3 is common. Let me take 3 into, so 2 is not only 1, 2 here I have, that is 2 square, I am going to take that also, into I have remaining 5 here, I am going to take that also, and also 7. So I am going to take that also. So it results in, so for 2 2s are 4, 4 3s are 12, 12 into 5 into 7, again 12 5s are 60 into 7, so that is 420. So the LCM is nothing but 420 for these two numbers, three numbers, that is 12, 15 and 21. So this way we can find the HCF and LCM of the given numbers. Now the amazing relation is, we have the concept that is LCM into HCF is equal to A into B, where A and B are the numbers. Okay, so here if you consider any two numbers, for example 12 or 15 or 15 or 21, and this is the relation. So here we can take like LCM is equal to A into B by HCF, or HCF is equal to A into B by LCM. So this is the amazing relation we have solving HCF and LCM. If any one of the things is given, for example LCM is given, we can find the HCF because already A and B will be knowing, and if they have given HCF we can find LCM, or LCM we can find HCF. So this way we can find numbers with this relation. And so here I have used the 3 numbers. I have given you relation for 2 numbers, and I request you people to comment the relation for 3 numbers. When they give 3 numbers, you write the comment the relation for these 3 numbers, HCF into LCM, the relation between these two for 3 numbers. I have given you the relation for 2 numbers, you can write for 3 numbers. If not, I will be starting that in the next video. So this way we are going to find the HCF and LCM of 2 numbers or 3 numbers by prime factorization method, that is using the fundamental theorem of arithmetic. So whatever the numbers we can find this way. And now in the next video I will be coming up with the word problems of the entire real numbers chapter of 10th CBSE, the entire types of word problems, and also I will be doing to prove a number is irrational. For example, root 5 is irrational, root 2 is irrational. All such type of problems I'll be solving in the next video, and I'll be coming up with word problems. So please like my video, comment and share. Don't forget to subscribe my channel. We'll have a great journey through mathematics and science. And here, you subscribe my channel and click the bell icon for the notifications. And I'll be waiting for your comment. What is the relation between HCF and LCM when the numbers are 3 or more? So hold on, catch up with mathematical concepts, and I'll be coming up with the next video, that is the natural concept, natural phenomena and the mathematics behind that. So until then, stay mathematically inclined. Bye, take care.